So first, data lake analytics, the status quo, right? Data lake, when you talk about data lake is, in my opinion, is um, on a cloud object storage or on HDFS, right? So it's very cost effective and is the one place that we just store all kinds of data in there. We just throw it in and forget about it, right? And when we need it, we kind of fetch them into a tool that is designed for that kind of workload, right? And do that, right? But there have been a lot of development in the data lake field, especially in the past few years, right? With the new emerging data uh, like open lake table formats, for example, Apache Hudi, Iceberg, and Delta Lake, right? They're giving data lakes, data warehouse-like features, such as transactions and schema evolution, compaction, time travel, and DDL support, right? Um, so they're kind of making, they're kind of building houses on the lake. Uh, so they're making data lake house, right? So it's basically a great combination of the features of data warehouse plus the cost effectiveness and scalability of data lake, right? So it's safe to assume that data engineers are developing analytics workloads on the data lake house, right? Or are they actually doing that? So from my experience, I'm kind of active the Star Wars community, the open source community, as well as talking to our clients, seller data. That's really not the case, right? The reality is users are still copying their data out of the data lake purely for query acceleration purposes, right? Like in this image, you can see people moving little boxes out of this house. So there, that's taking the data out, taking the workload out. Hope that was clear. And the reason being, existing data lake query engines, they're not performant enough for a lot of the more modern workloads, right? They're either not optimized for high concurrency or low latency workloads, still optimized for batch, talking about USpark, or they're still on older technologies, right? They're not taking advantage of all of the crazy optimizations we can do with modern software and hardware, specifically hardware, right? So they're not able to handle some very demanding analytics workloads on the scale of data we have, and on the workloads such as customer-facing analytics, where the concurrency and latency requirements are insanely high, right? So as a workaround, users are still forced to move the workloads to a high-performance data warehouse purely for query acceleration, right? This does really solve the problem. It makes the query fast, but it also introduces a lot of challenges and a lot of costs that's involved, right? So the first is that you're introducing a data warehouse. So that's a infrastructure level software. No matter how easy the deployment is, it's still a database, right? A database is stateful and is kind of expensive to maintain, right? And also you have to consider the cost of the data ingestion pipeline, right? Data ingestion not only to maintain this pipeline, but writing your files from a open file format like Parquet to a proprietary file format that takes a lot of CPU power as well, right? And also it introduces lag to your data freshness, right? And make your data less fresh. And also there's challenges, integration challenges, matching the schema, the data type, SQLs, and blah, blah, right? Et cetera, et cetera. And also you're copying your data. You're not keeping your single source of truth on the data lake, right? You're copying your data into somewhere else, and you have to somehow keep them in sync with all of the appends, even data updates that's happening, right? And that can introduce a lot of data governance challenges from doing that.